Okay, guys, let's review equations and inequalities. So first, let's take a look at a two-column proof. The first thing we're going to do is write the problem. So this always goes in the first statement row of your statement column. The reason is because it is the given. So the problem is always the given. The next thing we need to do to solve for x is we need to apply the distributive property. So this gives us negative 4x plus 8 plus the 8x, and then go ahead and distribute on the right. We have 2x minus 6. Then we can collect like terms. So we're going to collect negative 4x and 8x. So we're going to combine like terms. So negative 4x and 8x is 4x plus 8 equals 2x minus 6. Now, remember, when we have variables on the left and the right, address the variables before the constants. We have a 4x on the left and a 2x on the right, so to get them together, we're going to bring the smaller one over, so we're going to subtract 2x, so we're going to apply the subtraction property of equality. And when we subtract 2x to both sides, we get 2x plus 8 equals negative 6. Now we're going to isolate x. We're going to subtract 8 from both sides. So we're going to apply the subtraction property of equality. And when we subtract 8 from both sides, we have 2x equals negative 14. Now we are going to divide both sides by 2. So we're going to use the division property of equality. And this gives us x equals negative 7. And we're going to describe this as exactly one solution. There's only one number that if I plug into the original equation, everywhere I see an x, the left side will equal the right side. Okay, let's take a look at another example. We're going to write this in our statement column, the problem. Again, this is the given. We are going to distribute, so apply the distributive property, and we get 4x plus 8 equals, and we distribute 1/2, 4x minus 2. So over here, I'll just show my work. We never show the work inside the column. So again, we're going to address the variables first. They actually are the same. So when we apply the subtraction property of equality, we are going to get 8 equals negative 2. So we have no variables and we have a false statement, therefore there is no solution. Example number 3. This is the given. We are going to apply the distributive property, and we get negative 12x plus 18 equals negative 12x plus 18. We have variables on both sides. Address the variables. Now, this time, to make the variables cancel, we're going to add 12x to both sides. So we're going to apply the addition property of equality. And we're left with 18 equals 18. So this is a true statement when we have no variables left, but a true statement, this tells us we have infinite solutions. Okay, now let's solve this multi-step equation without a proof. So x is being squared, then it's being multiplied, then it's being subtracted, and then divided, and then lastly, the operation was add. So if we knew what x was, that's what we would do. We would square the value, multiply, subtract, divide, then add. Well, we are going to work backward and apply the inverse operation. So first we're going to subtract. So let's subtract 6 from both sides. So that's where the property of equality comes in. When we do what we do on the left, we do on the right. This gives us 3. Then we're going to undo division by multiplying. So we're going to multiply both sides times 2. Cancel those out. So now we have 3 times x squared minus 21 equals 6. Now we're going to undo the subtraction by the addition property of equality. Then we're going to undo the multiplication by the division property of equality. Then we're going to undo the squaring by the square root property. And when we take the square root, we need to use the plus and minus because every root or every number has 2 roots. So our answer has exactly 2 solutions. Because when we square, when we plug in, if we were to plug in the -3 in for x and we square it, we would get +9. If we plugged in the +3, we would get +9. So both answers, both values make this equation true. The left side will also equal the 9 once we plug in. So our properties would be subtraction property of equality, multiplication property of equality, addition property of equality, division property of equality, and then square root property of equality. So this, going from bottom up, this would be the order in which we would undo this equation. The perimeter of a rectangle is 126. The length is 12 less than 4 times the width. So our formula, we're going to write our components in alphabetical order, capital letters in the formula. The length is 12 less than 4 times the width. We know nothing about the width, so let's let that be our variable x. To represent the length, we're going to flip the 12 less than to the back. So we're going to have 4x minus 12. We're going to use the formula to write our equation. I'm going to go ahead and put my equals 126 at the end. So we have 2 and then our parentheses, and the length is represented with 4x minus 12 plus 2 times, we're going to put in x for the width. That's our equation. We're going to distribute and solve. So we get 8x minus 24 plus 2x equals 126. We're going to combine like terms. We're going to have 10x minus 24 equals 126. We're going to solve for x. We're going to add. Then we're going to divide. And x is 15. So this is the width. So x is 15, the width is 15. Then to find the length, we plug in 15 for the x. 4 times 15, that is 60 minus 12, and this gives us 48 for the length and 15 for the width. Joni is 10 less than twice as old as Robin. Lori is 12 more than half as old as Robin. The sum of their age is 107. So we have, and I want to do alphabetical order, Joni plus Lori plus Robin equals a total of 107. The person we knew the least about was Robin, so we're going to let Robin be X. Joni is 10 less than twice, so we're going to flip that around to X minus 10. Lori is 12 more than half Robin, so I'm going to say 1/2 times X plus 12. And then I'm going to use the formula as a little checklist. So for J, we're going to say 2x minus 10 plus, for Lori, we're going to use 1/2 x plus 12 plus, and then for Robin, we're going to use the x equals 107. Now let's combine our x terms. So that's 2, 1/2, and another 1. So that is 3 and 1/2 x. And then we have minus 10 and plus 12. Now I like to convert my mixed numbers into improper. So 2 times 3 is 6. 6 plus 1 is 7 over the 2 times x plus 2 equals 107. We're going to subtract out the 2. We have 7 over 2x equals 105. We're going to multiply by the reciprocal. X equals 7 divides into 105, 15. And then 15 times 2 is 30. So Robin is 30. Lori is half of 30, which is 15 plus 12, and that gives us 27. And then Joni is 2 times the 30 minus 10. So that's 60 minus 10, and that gives us 50. Okay, let's look at this literal equation. We're going to solve for x. So we have squaring, we have multiplying, we have adding, we have dividing, and we have subtracting. So we're going to work backward and we're going to add first. So we're going to add e to both sides. The q was first, it comes first. And then we're going to undo division by multiplying. So we're going to multiply both sides by r. And yes, we do need parentheses. Cancel. So we have 3x squared plus k equals r. And I like to put that coefficient out front. Then we're going to undo add by subtracting. So we're going to subtract the k. It goes at the end. Then we're going to undo multiplication by division. So we're going to divide this entire expression by 3. So we have x squared equals r times q plus e minus k all over 3. And then we're going to undo squaring by square rooting. So when I take the square root, that undoes squaring. And then I'm going to remember we need a plus or a minus. So make sure you have your plus minus. And this entire expression is underneath the radical. And that's your final answer. Okay, here we have some inequalities graphed. And so we're going to write this in interval notation. So we're going to start with 1 and go to positive infinity. 1 is not included. And infinities always use a parentheses as well. For our next example, again, we go from left to right. So the shading begins at negative infinity. It goes up to the -2, and -2 is not included. So the shading begins from left to right at -4. It is included, it's closed, so we need a bracket, and then it goes all the way to positive infinity. On our fourth example, the shading begins from negative infinity up to the -2, and it is included, so we need a bracket. Here we have a compound inequality where it's and. So we're going to start at -1. It is not included. Remember the comma represents the shading, and it goes up to the 5, and it does include the 5. Our next one is a compound inequality with an or statement. So from left to right, everything has to be from least to greatest. So we're going to unite from negative infinity up to -3. we're going to use the U to unite this left shading with the right shading, and then it picks up at -1. It is included and goes to positive infinity. So all of this notation matches up with our number line. Let's solve, graph, and notate. So we're going to add 2 to both sides. We're going to divide by 8, and x is greater or equal to 0. So on the number line, it's always a good thing to graph when you're having to do integral notation. So x is 0 or greater. So this is closed up. And so interval notation, 0 with a bracket to positive infinity. Our next one, we're solving for x. We're going to subtract 6 from both sides. We have -1/2 x is greater than -4. We are going to multiply by the reciprocal, which is going to be -2. And remember, when you multiply or divide by a negative, we're going to flip around the inequality. So we get x is less than +8, okay? So remember, if you multiply or divide by a negative value, if your x is negative, you're going to be flipping around your inequality. Our x is not including 8, so it's open and it's shaded to the left. So our shading starts from -infinity from left to right up to 8 and a parenthesis not included. Here we have an and inequality. We're going to add 8 to the middle, to the left, to the right. We're going to have 20 is less than or equal to 4 times x, which is less than 24. We're going to divide by a +4, and we get 5 is less than or equal to x is less than 6. We have a 5 and a 6. This is saying x is equal to 5 or greater and less than 6, but not equal to 6. So it's sandwiched in between. So we have a bracket, and then we have a parenthesis. And our last one, we have our OR statement, compound inequality. We are just going to solve these independent of one another and graph it on the same number line. So one condition is x can be less than -1, or x can be equal or greater than 12. So we're going to consider -1. So x is either less than -1 or it's equal to 12 or greater. So we're going to have -infinity up to the -1, not included, and we're going to unite it. That means union with 12 to positive infinity.